Oh, I forgot to do the image bank. Okay, guys, look at 3.6. You should be on 3.6. Number 2. Okay. Oh, this is crooked. There we go. Okay, Philip and Colton are racing their remote control cars. We read it and we didn't have time to finish it. Philip's car travels this many feet per second. Colton's travels this many feet per second. Because Colton's is slower, Philip gave him a 9-foot head start. Write the equation that will determine how many seconds Philip will need to catch up to Colton. That means be even with him. Have the same distance. Be at the same place. So, look right here. We've got Philip. There's the start line for Philip. And then Colton is going to start how many feet ahead? 9 feet ahead. So what I'm trying, is it better? So what I'm trying to do, guys, is find out how long it's going to take Philip to catch up and be even with Colton. It'll be down here somewhere. And Philip will be here, Colton will be here after so many seconds. Okay, Philip is going 4.5 feet per second. Colton is going 3.75 feet per second. How do we find the distance? Who remembers the distance formula? What do we multiply? Rate. Nobody remembers? Rate. Angel, you don't remember either? Did we do this yesterday right here? Oh, okay. I didn't know if I had time or not. Okay, so you're going to find distance. You're going to multiply rate times time. Now, in science, they'll put an S for speed. The same thing, rate of speed. So, to find distance, you're going to multiply the rate of speed times the time. Tell me this. If I put my cruise, I'm on I-10, I put my cruise on 60 miles per hour. How many miles can I go in 1 hour? If I'm going 60 miles per hour, how many miles can I go in 1 hour? 60 is not a trick question. Y'all were right. 60. You just weren't very confident. You're going to go 60 miles in 1 hour. So in 2 hours, you would go how many miles? 120. Okay? So you're going to multiply the rate of speed times the time. So to get Philip's distance, how far he's going to go, I'm going to multiply 4.5 times S. That's going to give me Philip's distance. Colton's distance, his distance is going to be figured by 3.75 times S, the seconds. We don't know the time. We're trying to find out the time. So to make them equal, we need to do something to this equation because they're not going to travel equally the same, right? Colton got a what? Colton got a what? 9 foot. So where are we going to add 9? Which side? To Colton's side to make them equal. Guys, you see where Shelby got that? To make them equal, we have to add 9. We have to add 9 to Colton's. Okay. So, now we're going to solve it. What are we going to circle? The S's. Get your calculators ready. Okay, draw your river. What am I going to do first? There you go. So I'm going to subtract 4.5 minus 3.75. $0.75S. Good. Now what am I going to do? To find S, what do I need to do? What do I need to get rid of? Eliminate. 0.75. No, I don't want to eliminate the S. I want to eliminate the 0.75. I'm going to divide. So 9 divided by 0.75. What does that give me? 12. So in 12 seconds, guys, in 12 seconds, then Philip is going to catch up with Colton. And they're going to be neck and neck. They're going to be equal. Their distances will be equal. Oh, how do we check this? 4.5 times 12 equals. Leave it there. Good. 3.75 times 12 plus 9. Good. So 12 seconds is our answer. Okay, look at number 3. 3 is a little tricky. Okay, guys? So just listen. I'm going to try to explain the best I can. 3/4 of an acre produces 36 pounds more corn than 1/4 of an acre. How many pounds of corn does an acre yield? So we're trying to find the pounds of corn for 1 acre. Everybody go draw me a square. I want to know how many pounds I can get off that 1 acre of land. All right? So I'm trying to find out the pounds of corn for this 1 acre. But this is all they give me. This is all they give me. That 3/4 of an acre, you get 36 pounds more than the 1/4 acre. So if I put 3/4 times P, 3/4 of an acre times P, that tells me how many pounds for the pounds for 1 acre times the 3/4 gives me the pounds. And then if I put 1/4 P over here, they're not equal, are they? Because in 3/4 of an acre, you're going to get how many more pounds? 36. So I need to add 36 to this side. And once I find P, then I know how many pounds for 1 acre. So let's think a minute. If I know the pound, if I know P, that's how many pounds for 1 acre. So let's say it's 60. Let's say it's 60 pounds for an acre. I don't know. 60 pounds for an acre. Then I would take 3/4 of that 60, and that gives me how many pounds for that 3/4 of an acre? Because it's 3/4 of it. 3/4 of an acre. Same thing with 1/4 of an acre. If it's 60, then 1/4 of 60 is 15. So it'd be 15 pounds for that 1/4. To make them equal, I've got to add 36. Okay, we're not going to solve that. Okay, number 4. 4/5 of an acre produces 45 pounds more strawberries than 1/5 of an acre. So how many pounds does an acre yield? So we're going to put 4/5 P again equals 1/5 P, but where am I going to add the 45? To the 1/5. To make them equal, we have to add the 45 to that side. No, we're not solving these two. Okay, on the back, number 5. Now this might help make it a little easier. This one might be a little more that you can relate to. Kennedy earns $15 an hour, but makes $100 less a week than Sydney, who makes $20 an hour. Find how many hours each will work in the week. So we're trying to find how many hours they work. So let's put H for the hours. What does Kennedy make? 15 an hour. And what does Sydney make? 20 an hour. Are their paychecks going to be equal? No. Okay. Oh, thank you. I got it too big, Donna. Okay. So Kennedy makes $100 less than Sydney. So what do I need to do to Kennedy's to make them equal? Yes. If I add 100 to Kennedy's, then they'll be equal. Is this making any sense? Okay. Okay. So let me say it one more time. I'm trying to find H. So I have to, the hours they work, I have to use what they give me and try to set an equation up that has H in it. Well, I know that Kennedy makes 15 an hour and Sydney 20 an hour. I want them to be equal. I want it to be equal. Well, they're not equal. But Kennedy makes $100 less than Sydney. So if I add 100 to Kennedy's, then they're going to be equal. Does that make sense? So, look, if you have $10 more than me, then I need to add 10 to mine, and then we'll be equal, won't we? Okay? All right, good deal. We're not solving that one. Number 6. Both figures have the same perimeter. What is the perimeter of each figure? Okay, this is going to be x plus 4. This is a rectangle, and this is x. Opposite sides are congruent. So how do I get the perimeter of this rectangle? Please don't say length times width. That's area. How do you get perimeter of a rectangle? Add around. Add around it. There you go. Rim is around. So add all the x's. How many x's do you get? 4 x's. 4 plus 4? 4 plus 4? I'm beginning to wonder. Guys, I'm just adding around. Adding around it. X plus x plus x plus 8 is 4 x's. Okay? Now let's add the triangle. How many x's are there? 3x, and these are plus signs, guys. So what's that? 7 plus 9. When we solve that, when we solve x, and we know x, are we going to have the perimeter? Will we have the perimeter? X is not going to tell us the perimeter, is it? Then we've got to put that number in for x in either one of these, because they have the same perimeter. It won't matter which one we put it in, and we'll get the perimeter. Okay? Okay. No. Number 7, Monday. We're going to solve on Monday. Okay, number 7. Both figures have the same perimeter. How do you get the perimeter of a square? No, not side. You're not multiplying. You're taking the side and multiplying by 4. Excellent. You're taking the one side and multiplying by 4. So 4 times what? 3x, huh? Right? 4 times 3x. And that equals, same that we did up there. So how many x's are there? 4 x's plus, what's 20 plus 20? 40. Okay, now what's 4 times 3x? Very good. And we're not solving it. Put this in practice. Leave your binder open. Oh, I apologize. Put this in your binder in practice. Leave your binder open to practice, because the next thing we're doing is going in there. Okay, now, guys, I marked this out, and then I meant to put it back, and I forgot before we ran it off. It is worksheet 3.7. Okay, so let's add these boxes of money. How much money is in A? How much money is in A? 16 cents. You're scaring me. B, how much money? 15 cents. C, 17 cents. Okay, now here's what I want you to do. You're going to read the verbal statement. In fact, let's do, oh, sorry. Hey. Okay, let's read the first one, and I'll tell you what. Okay, so the box contains at least 16 cents. Guys, if I say I want at least 5 of you to answer this, right? How many people do I want to answer it? 5 or more. If I say at least, I have at least $50 saved up, then I know that I have $50 or more saved up, right? At least. So, the box contains at least 16 cents. What's it going to be? 16. I know, but which boxes? A, B, C, A and B, A and C? A and C. Those two boxes have at least 16 cents. Now, everybody underline at least. Say at least. So that money that's in these boxes, the T, we're going to use what we call an inequality sign. We're going to use inequality signs on this, not equal signs. Here they are. Less than, that's less than. Oh, excuse me. That's less than. And look, it looks like an L. Like a laid down, like a little L. That's less than. Greater than. Now, these two you may not have, well, you saw them last year, but you may not remember. Less than or equal to, and then greater than or equal to. You just put one bar under there, and that means it could be equal. So like I said, I want at least 5 people to know this answer. I want 5, it could be 5, or I want more than 5. Does that make sense? Okay, so what symbol, which one of these symbols am I going to put here? I want this money. How much money is in A? 16. How much is in C? 17. So that total is going to be greater than or equal to 16. Greater than. Greater than. Okay? I'm going to read B, the second one, and you're going to choose the box. Don't say anything. Just write the letter of the box you think it, or boxes that it shows the answer. The box contains less than 16 cents. What'd you put? So what am I going to put over here? Less than. Not equal to. It's less than 16. If I say I want the people that are less than 13 years old to go to the gym, I don't want 13-year-olds. I want those that are less than 13. You see? Okay? All right. The box contains, oh, right. Hey, underline less than. The box contains at most 16 cents. At most. At most. Okay? What I say is at most I want 10 people on that ride. At most, I want 10 people on that ride. Well, no, 10 people. So I want, how many people do I want on that ride? 10 or less. At most, I have $50 saved. So that means I have 50 or less, because I made 50 raking and mowing and stuff, and I can't remember if I spent any of that money or not. So I know I have at least $50. I mean, at most $50. At most. That's the most. $50. So I have 50 or less. So what are you going to pick? So what am I going to put here? Less than or equal to. And a lot of people get confused because they see the word most, they think greatest, and they go in there and put the greater than symbol. But that just means I have at most 16 cents. Okay, the box contains greater than 16. C, and just your greater than symbol. That one's easy. The box contains no more than 16 cents. Now, a lot of people get it with me saying no more. They get that. But I add not, and more people get that. The box contains not more than 16 cents. So it's going to be not more, but less than 16 cents, right? So what's it going to be? A and B. So no more than. So I can say I want no more than 10 people on that ride. 10 people can get on the ride or less. It just takes a little while to learn this. Not more than, but less than. But it can include that 16. The box contains no less than 16 cents. Not less than, but more and equal to. So A and C. So it's going to be what? Greater than or equal to. Okay, I hope I didn't confuse you. I hope I made it easier. Okay, everybody look at number on 1 through 6. 1 through 6, guys. I want you to go down, and we're going to be writing inequalities, not equations. So you're going to be putting less than, greater than, less than or equal to, or greater than or equal to in these. They're not called equations when you have those symbols. They're called inequalities. Say that with me. Inequalities. Inequalities. So you're going to have one of those symbols when you write this. So I tell you what, let's do number 1 together. No, let's do 2. 2's a little harder. 4 more than the quotient. What does it mean when we do quotient? Divide a number in 3. So 4 more than, I'm going to put plus 4. I'm going to add 4 to something. What am I going to add 4 to? N divided by 3. And write it that way, please. N over 3 is at least 9. This is at least 9. So that means it's going to be greater than or equal to. Hey, look on the front. Guys, look on the front. At least was the first one we did. It's going to be greater than or equal to. This amount has to be at least 9. At least 9. That means you might not remember your cousin's age, but you go, I know they're at least 9. That means you know that they're 9 or more than 9. They're at least 9. Okay? So you're telling me their age is at least 9. So that it could be equal to 9 or greater than 9. Okay. I want you to go try to do 1, 3, 4, 5, and 6 right now. I'm going to give you just a little bit of time. Those working, listening to this, stop the recording, and then when you finish with 1 through 6, then turn it back on. All right. What did you get for number 1? When it says sum, what do you know you're going to do? Add. What are you going to add? No. A number and 14. Or you could put 14 plus n. Less than or equal to 3n. Good job. Good. Number 3. 7 more than. So that tells you you're going to do what? Add. So I always go plus 7. What am I adding 7 to? 5/6 of a number is more than -3. Now the order could be different. You could put 7 plus 5/6 in right there. Yes. No. No. The only thing you can change is the order right here. There's no, look, it's 7 more than. There's no n multiplied on 7. It's 7 more than 5/6 of a number. It's the only way it can be written, except turn that around maybe. Okay, number 4. 5 times a number n decreased by 8 is at most, now that order has to be like that. No, wait just a minute. Is at most, yeah, 10 more than twice a number. Now, what sign are we going to put it when it says is at most? Yes, ma'am. Guys, all you had to do was look on the front page. Look, all you had to do was look. Who looked over there to find that symbol? Okay. Well, some of you are acting like you're erasing. This could be different. I mean, that could be in 10 plus 2n. But this has to be just like it is. Okay, number 5. 1/4 of a number decreased by 3 is at least 2 greater than or equal to. This is at least 2, so it's 2 or more. Number 6. The sum means what? Add. The sum of 12 and a number, or you could have that backwards, it doesn't matter, is no greater than, it's not greater, so it's going to be less than or equal to the sum of twice a number and -8. And you can put that in parentheses if you want. Okay, good. Okay. Who got all 5 of those right I told you to do? Okay. Several people. Okay, number 7. Guys, one reason we don't finish is because we don't start when I say go. Yes. Okay, number 7. Allie has $120 to buy 8 Christmas gifts. If she spends the same amount on each, what is the most she can spend on each gift? So let's think. She's got $120. $120 to spend. She's going to buy 8 gifts. How can I don't know the cost of each gift, but when I find the cost, what do I do to the 8 to find the total I've spent? Do I add the number of gifts? Can I subtract or add the number of gifts and the money? Yeah, I'm going to multiply, aren't I? I'm going to multiply 8 times the cost. 8 times the cost. That's going to give me the total cost I'm spending. So what symbol am I going to put in here? Y less than or equal to? Yeah, she only has $120. She can't spend over that. You see? So this has to be less than or equal to 120. Jared's youth group is having a car wash to raise money to go on a mission trip. They're charging $6 for each vehicle. How many vehicles, everybody underline that. How many vehicles, that's what we're trying to find out, should they wash to raise at least $1,500? So what are they charging per vehicle? No, what? Oh, 6V. 6V. So they're charging $6 for every vehicle. So if they wash 5 vehicles, how much have they made? 30. And that's not enough, is it? No. They're trying to make $1,500. What symbol should I put in here? Because they want at least $1,500. If they make less than $1,500, they're not going to have enough money to go. They'd love to make more than $1,500 because then they could take more supplies to the people or whatever. Okay, number 9. We're back. Yeah, that's what gets us. Okay, number 9. Now we're back to the remote control cars. We're back to remote control cars. James and Jared are racing again. James' car, the circle James, and he goes that fast. Jared's goes that fast. Because James's car is slower, Jared gave James an 8-foot head start. Uh-oh. Here's where it changes. Which inequality could be used to determine after how many seconds Jared's car will be ahead of James's car? We don't want to know at how many seconds it takes to get to the same place. I don't want to know they're getting to the same place. I want Jared to be ahead. I want Jared's car to go ahead. How many seconds is it going to take for Jared to pass him up? Not to get even with him. To pass him up. Okay? So we've got James. Let's put James over here. And Jared over here. James's car goes how fast? What is his rate of speed? Good. And we multiply by the seconds, remember, to get the distance. Rate times time. And Jared's goes what? 5.25 times the seconds. Okay. Are they equal? Are their times equal? No. Okay, so remember, Jared is giving James an 8-foot head start. So what do we need to do with the 8? Add it to James. Good job. Now, do we want to know them being equal, the same distance? We want to know when Jared gets ahead. So we want Jared's to be more than. So the symbol needs to go to, the math needs to open up to Jared, huh? Since we wrote it backwards.
We can't say less than and greater than?
Well, because we're going, I know, well, we just put the symbol in there. Okay, I'm going. Okay, look at number 10. So James, let's go back to number 9, I'm sorry. James's time is going to be less than, his distance is going to be less than Jared's, correct? Jared's is going to be greater than. This is going to be greater than. Okay, I tell you what, we're going to stop right there so you'll have time to put this back in practice. Put this back in practice. Yes.